All right, today's 7th graders, we're going to talk about, in lesson 8-7, systems of equations. A system is a word, a term in math that means more than one, okay? If you're solving a system, it means you're solving a set of equations. More than one equation. You're finding the point, the coordinates, that make both equations true, okay? It's kind of like if you have a number that has a sum of 20 and a difference of 4. Two numbers that have a sum of 20 and a difference of 4. Okay? If you were to write that out, that would be like x plus y equals 20 and x minus y equals 4, right? And could you find a solution for this? Meaning a set of numbers.
12 and 8.
12 and 8, right? 12 and 8. 12 plus 8 equals 20, and 12 minus 8 equals 4. We just solved this system of equations. Okay? What is the x-coordinate in the system?
12?
12. Right. So the solution is 12, comma 8. Right. Yep. And we can graph these as well. Right? How could we graph this? X plus y equals 20.
You just go over 12 and 8.
Over 12 and up 8.
Just 12, 8 right there.
Okay. I see what you're saying. We could graph this point, but we could also graph these as equations, right? So for example, if we were going to graph x minus y equals 4, we could make a t-chart, x and y, and find numbers that work, right? What if y was 0? What would x be? 4, right? Because 4 minus 0 equals 4. What if x was 2? Can you do that one? 2 minus what number equals 4?
-2.
Negative 2, very good. 2 minus negative 2 equals 4. So 2 and negative 2. And then we could graph these, couldn't we? 4, 0. And 2, negative 2. And draw this line, right? And then if we graph this one, we would draw another line. It would kind of go like this. It would be up here at 20 and then go down to 20. I kind of made my graph too small for this. But you would see where these cross, and where would they cross? Can you predict where they would intersect based on what we already know the solution is? The solution is 12, 8, right? So they would cross at whatever that point is. It's 12, 8. Okay? We would be able to graph these and find that. Okay? Now, if we go back to what we're learning about today, We can do the same thing with any two set of equations. We can find, and see if we can find a solution by graphing them. Okay? Let's take the equations that are given in number 1 on your sheet.
What's that?
On the practice side, I'm sorry, on the reteaching side. Let's start with those. 3x plus y equals -1. Let's start with that one. 3x plus y equals -1. What's the other equation?
X minus y equals -2.
X minus y equals -3. Now, they're not quite as easy to solve as the one that I gave you to start with. Right? In fact, we could graph these in a couple different ways. We could make a T-chart and graph it that way. Or we could put them in y equals mx plus b form. That's probably the simplest way to graph them, because then we can just mark the y-intercept and then mark the slope and graph the line. Okay? How could we get the y by itself? How could we solve this for y? Okay? Eyes on me. Look up here. How could we get this solved for y, meaning the y is by itself, Dylan? Look at look at this side. Let's get rid of this. We can work with this equation. So on this side we have 3x and y. On this side we have -1. Go ahead. Yep. Add -3x. So we can add it to this side. Right? Because we can't subtract 3x from this side. So we're going to add it, the negative. And y equals -3x plus -1. Can we easily graph this then, Hunter? Quit moving around, guys. Focus up here. How would we graph this? What is the y-intercept? -1. Yep, this is b. And b is -1. So we go down to -1 and mark b. Go ahead and do that. What is the slope in this equation? Isaac?
-3x.
-3. Not the x. It's just the number, right? M is -3. So from this point, we would go down 3 and over what? What, class?
1.
1. Over 1. We can't just go down 3 because this is a fraction. It's not -3 over 0. It's -3 over 1. So you always have to go over something when you're graphing a slope. Okay? So we've got 2 points and we can draw our line. We could go down 3 over 1 again. Or we could go up 3 and left 1. This forms our line. And one of the things about this, what we're doing in this skill, is it is helpful, whoops, I put that one in the wrong place. It is helpful to mark more than one point on the line, okay? Because we might use a different point as our solution. You'll see what I'm talking about when we graph this one. Let's graph this one now. James.
Plus negative, or plus y.
Plus y.
Yeah.
So we're going to solve this. You want to solve this for y again? That's good. Okay, that's okay. So we can solve this for y. We can also, what do we have to get rid of then on the same side as y, James? -3. So add 3 to both sides, right? So y equals,
X plus 3.
yep, x plus 3. Good. Now, it's still in the y equals mx plus b form, class, but the terms are moved around because of the commutative property, because we can switch the terms around because of the commutative property, right? What is b then?
3.
3. Good, Michael. Yep, this is b. And what is the coefficient of x? Lydia?
1.
1. So the slope is 1 over 1. Right? Let's mark this on this graph. We mark it on the same graph. Mark 3, because that's the y-intercept. So 1, 2, 3. And then from here, go what? Keyshawn? How do we mark the slope from here?
1.
And?
To right.
Yep. See, it's 1 over 1. Up 1 and right 1. And we can go down and right. And what do you notice? Where does it cross? Go ahead and draw that line on yours, on your sheet. Where does it cross? Where did it cross on your graph? Joey? Negative 1, 2. At this point, negative 1, comma 2. This is the solution to the system. Okay? What that means is these two numbers make both equations true. Let's check this. How could we check to see if this is the solution? What is the x number? Joey?
X number would be
Negative 1. So we're going to put that in for x. What's the y number?
2.
2, right. Let's put that in. 3 times x, so 3 times, say it class. Where did that come from, Dylan? Yeah, negative 1, the solution. Plus y
2.
equals negative 1. Is that true? Yes. That is true. Does it make this one true? Dylan, where are you going? Oh, okay. X minus y equals negative 3. So, what is the x number? John?
The X number is negative 1.
Negative 1 minus, what's the y number, Noah?
That would be negative 3.
No.
Oh,
2 equals negative 3. Is that true? Negative, oh, I'm sorry, I wrote this wrong. Negative, whoops. Negative 1 minus 2. Is that negative 3? Yeah. So, since it makes both equations true, we know that it is the solution. Alright, when you find the point that it crosses, then you can check it in the original equation to see if both numbers make a true equation. You replace the x number for x in the equation, the y number for y, and you should get a true statement, a true equation. Okay? So, what if, go to the back side. In numbers 1 through 3, it just says, is each pair a solution of the given system? Meaning that they give you a point like this, and they just want you to do this step. Just what? Just check it. Just put in x and y. Check the first one. On your piece of paper, the first equation is y equals 6x plus 12, right? And the second equation is
2x minus y equals 4.
2x minus y equals 4. And what do they give you for a solution?
Negative 4,
Negative 4,
12.
Oh, negative 4, negative 12. What do we do with this? Noah, what do we do with this?
Check
Yeah, we put this in for the, what? The x number. Put this in for the y number. And check to see if it is true. So is negative 12 equal to 6 times negative 4 plus 12? Is that true?
Yes.
Yep, because negative 24 plus 12 is negative 12. So that's true. But it has to be true for this one also. Is it true for this one, Chase?
What?
Yes.
2 times negative 4
Final answer.
minus negative 12. Is that equal to 4?
Yes.
Negative 8 plus 12, right?
That's equal to 4, Troy.
So this one is true also.
Come back.
So is this the solution?
Yes.
Okay. That's the process. Graphing them to find a point of intersection or putting in the point.